students, in today's lecture we will be discussing about the formation of multiple images whenever we have mirrors which are parallel to each other or inclined with each other. So, we will find how many images will be formed, where will the images be formed, and later on we will discuss about the velocities of the images whenever an object is moving or a mirror is moving. So, what would be the velocities of the image in cases like that. Okay. So, we will start off with image formation in the case of plane mirrors which are parallel to each other. So, this is the scenario. So, you have two plane mirrors. So, let us consider that this is mirror M1 and this is mirror M2, and there is a point object which is placed here in between the two mirrors. Let us say it is at a distance of A from M1 and B from M2. So, we need to find how many images are formed in this scenario. So, I guess you must have learnt about this earlier, that there are infinite number of images which are formed because there are multiple reflections which can occur in this scenario. Okay. So, we will see how that scenario of multiple images is formed, infinite images, and where will those images be formed. Okay. So, what I am going to do now, I will first take a light ray from this object onto the mirror M1. So, you can see generally we take two light rays, but by default you all know that the second light ray can be taken normally, which gets reflected back, which once again gets reflected back along this line. So, I am not going to draw that each and every time. I hope you understand that. So, I will just follow this light ray. So, this light ray after reflection from mirror M1, we can say that it gets reflected in this manner and it goes and strikes mirror M2. Okay, so this is the direction. Now, we all know how to locate the image. Whatever is the distance at which the object is present, at the same distance behind the mirror the image will be formed. So, the image in this will be formed over here, and this light ray appears to come from a point which is over here. So, if this is A, we can say that this is also A from mirror M1. So, now we know that the light ray which is reaching M2 like this after reflection from M1 appears to come from this particular point, right. So, we can say that this mirror M2 thinks that all the light rays which are incident on it, the other light ray which is coming horizontally as well. So, this light ray and this light ray, both of them appear to strike this mirror originating from this point. So, that is what the mirror thinks. So, we can say that this is the object for this mirror. So, as this is the object, now what is the object distance? We can say this is A, this is A, this is B. So, the whole distance will be 2A plus B. So, this light ray originates from a point at 2A plus B and strikes this mirror. So, now once this light ray gets reflected, the image is formed behind the mirror and you can easily tell where the image is formed. So, as this light ray gets reflected from here and goes on to the mirror M1, so we can easily say that because this length is 2A plus B, this reflected ray appears to come from a point behind the mirror which is also equal to 2A plus B. So, basically this mirror has formed the image of this object, which once again is the image of the first mirror. So, I hope this is clear. So, now let us look at this light ray. So, this light ray is now striking the mirror M1, right, and this light ray appears to come from a point which is over here, which is at 2A plus B from M2. If it is at 2A plus B from M2, what is its distance from M1? So, it is 2A plus B plus A plus B, which is 3A plus 2B. So, we can say that for this incident ray, the object distance is 3A plus 2B. So, this light ray will get reflected back once again in this manner. Now, where does the image form? Because this is 3A plus 2B, we can once again say that the image is formed at a distance of 3A plus 2B. Okay, we will stop here for now. I can't just keep going. So, similarly, this is not the complete case that is possible. I have just considered one half of the scenario, because light rays can travel directly from this, directly onto this side and strike the mirror M2 as well. So, if I consider that scenario, so if I consider one light ray which is striking mirror M2 like this, So we can say that this light ray gets reflected from here and goes like this, and we can easily say that the image of that is formed over here. Whatever is this distance, the image will also be formed at the same distance behind the mirror. So this is where the image will be formed at B. Now observe carefully once again. Now this light ray which is getting reflected from here while reaching this mirror M1 appears to come from here. So you can see the light ray appears to come from this point. So whatever is the image that is formed in mirror M2 acts as the object for mirror M1. Now observe what we are doing here. As this behaves like an object for M1, to calculate the object distance, see here I am considering this distance and I am adding a plus b. So b plus a plus b. So that would be the object distance for M1. So which is b plus a plus b, which is a plus 2b. So the light ray which gets reflected from here like this will appear to come from a point which is over here, and we can say that because this is the image of this, it does not look that way, I will slightly change it. Okay. So we can say that because this image which I have represented here is the image of this in this mirror. So this will also be formed at a plus 2b, and so on. We can once again say that this light ray gets reflected, and because for this mirror the light ray is coming from a plus 2b plus a plus b, which is 2a plus 3b. So the object distance for this mirror will now be 2a plus 3b, and so on. So that is the basic method which we will be using to locate different images. Now throughout this process, if you observe one thing, you would have observed that the image which is formed in one mirror is the object for the other mirror. So that is something which is common in all the discussion which we have done till now. Image of one is the object for other. Now when we are doing that from image of one to the object of the other, we are each and every time we are doing something which is common. So if you see here, this image which is formed in M1 is the object for this. To find the object distance, I am adding this image distance with a plus b as the object distance for M2. So whatever is the image distance of one plus a plus b will be the object distance for the other, which makes the same as the image distance of the other. I hope this is clear. So this is what we have done throughout this particular scenario. If you want, I will show you the other case also. B is the image distance in M2. Now because this is the object for M1, image distance in M2 plus a plus b will be the object distance for M1, and the same thing repeats. So now based on this idea, we can make a table over here to directly write down the distances at which the images are formed, M1 and M2. Let us say if I make a table like this, what I am going to write down here are distances from M1 and M2 of different images. So you can see that the first image in both is formed at A and B. So I will first write that down, A and B. Now the image which is formed at A in mirror M1 acts as the object for M2. So but when I am doing that, I am changing from one mirror to the other mirror, I am adding a plus b, because A is the distance from here will be plus a plus b. So what I can say is A plus a plus b will be the object distance for M2, which means that will also be the image distance from M2. So we can say that this plus a plus b, I will get 2a plus b. So I will write a line, I will draw a line like this, which means adding a plus b. Similarly, I will add a plus b here, I will get a plus 2b, which is the one which I have shown here. So this image which is at B from M2 acts as the object for M1. What am I doing here? Image distance in M2 plus a plus b is the object distance for M1, which is also the image distance of M1. So that is the basic idea. So each and every time if you take an image in M1, this acts as the object for M2. So, when I add a plus b, I get the object distance, which will also be equal to the image distance. So, this plus a plus b will be 2a plus 3b, and this plus a plus b will be 3a plus 2b, and you can just continue this process many times. Infinite images are formed. So, just use this crisscross method. So, whatever is the image which is formed in one will be the object for the other. So, when it acts as the object for the other, you add a plus b, which is the distance between the mirrors, and that way you can just find out all possible images. So, they can ask you questions like this. So, for example, let us say I ask you, find the distance of fourth image in mirror M2. So, what is the distance at which fourth image is formed in mirror M2? So, you can just directly write down a table, draw a table, and you can just find the fourth image. So, fourth image in M2 will be the one for which this acts as the object. So, when I do the crisscross method, I get 4a plus 3b over here. So, the answer for this would be 4a plus 3b. So, that is how we can understand the idea of infinite number of images which are formed in the case of parallel plane mirrors. So, I will just write it down here, infinite images are formed. So, do not think that these light rays, after some reflections, reflection here, it might go out of the mirror. So, yeah, it might go out, but it is not that only one ray is present in the, one ray is going to come out of an object, right. There are infinite number of rays which are going to come out of the object at even smaller angles. So, which means they undergo multiple reflections before going out. So, definitely you can consider that a large number of images are formed. Students, now we will discuss about image formation in the case of mirrors which are perpendicularly inclined to each other. So, you can see here. So, let us consider this is mirror M1 and this is mirror M2, and let us consider that there is a point object which is placed over here. So, considering this as the x axis, this as the y axis. So, the coordinates of the object are a comma b. Now, we need to find out where and how many images are formed in this particular scenario. So, you all know that for point objects and mirrors, we can directly use the perpendicular method, which we usually do. So, I will just draw a perpendicular onto the mirror M1, and I will just draw the same distance on the other side. So, this length we know that it is equal to b. So, at the same distance of b on the other side, we can say that an image is formed. Let us call this image as I1. So, this is basically the direct image which is formed in M1. So, if you consider a light ray which is striking like this and getting reflected. So, we can say that this reflected ray from mirror M1 appears to come from over here. Okay. So, it appears to come from over here. So, we can say that this is the image formed in mirror M1 for this object. Now, by using the same logic, we can say that if I draw a perpendicular line onto mirror M2, the perpendicular distance would be a, and at the same distance of a on the other side, we can say that an image is formed. Now, so let us call this image as I2, it is at a distance of a. And to understand how this image is formed, you can just draw a light ray like this. It gets reflected in this manner, and that reflected light ray appears to come from over here. So, for a person who is viewing from here, if he is looking like this, so he thinks that the light rays which he is receiving are originating from this point. So, he thinks that there is an image, there is an object which is present over there. Okay. Now, are there any other images that can be formed apart from these two? I have drawn I1 and I2, which are very straightforward. We can understand that as the direct images which are formed from mirror M1 and M2. Now, think and tell me, are there any other, think, can't tell me. So, think and find whether there are any other images which are formed in this scenario. So, yeah, there are other images also which can be formed, because when a light ray is incident, I have taken a light ray which is incident onto mirror M1 which gets reflected away. So, this light ray is not going to reach M2 again for sure, but if I consider a light ray which is incident in this direction, so let me draw that. So, if I consider one light ray which is incident like this, so after reflection this light ray will get reflected onto mirror M2. So, here we can say that this light ray will get reflected here in such a way that it appears to come from I1 and it goes and strikes mirror M2, correct. So, which means this light ray which I am drawing now, so this light ray which is striking mirror M2 appears to come from I1. So, which means I1 acts as object for M2. I hope this is clear. So, if you look at this light ray, so just look at this light ray and understand what that light ray tells us. So, this light ray is starting from here and going on to M2. So, this is the incident ray for M2. Now, what does M2 think? Where is that I2 coming from? Where is that incident ray coming from? Where is it originating? So, it is originating from this particular position. So, we can say that I1 acts as object for M2. Now, you can easily draw once again. So, this is the mirror M2, this is I1. Now, because I1 is acting as an object, you all know that even if there is no mirror here, we can extend it. We can assume that there is mirror, we can drop a perpendicular and then draw the image location. So, because I1 is behaving as an object for M2, there is a possibility of light rays which are reflecting from M1 to reach M2. So, light rays which are reflecting from M1 appear to come from here. So, which means there is a possibility of I1 acting as an object for M2. So, that is what I am drawing here. So, because of which we can say that I1 will also form an image in M2 and that image will be formed over here. So, this is not straight. So, here we can say that whatever is this distance, which is A once again, at the same distance of A on the other side, the image of I1 in M2 is formed. I'll write it down here. This is image of I1 in M2. We can directly say that this is the image of object in M1 and this is also the direct image. So, this is the image of object in M2. So, these two are direct images which are formed, but whereas this is the image of I1 in M2 and there is a possibility of that to happen in this scenario, because a light ray getting reflected from M1 can once again travel on to M2. So, there is double reflection which is possible. So, double reflection means image of an already formed image is possible. So, please understand it like that. So, multiple reflection means image of an already formed image. Okay. Now, what I have considered is done now. There is one more thing which I have to consider. The image, is it possible for a light ray striking mirror M2 to strike M1? Yes, it is possible. I can take another light ray which is like this, so which strikes mirror M2 and falls onto mirror M1. So, a light ray like this reflects M1 and goes away. Now, which means what I am trying to say is once it gets reflected here and goes like this, that light ray appears to come from here. So, which means this acts as an object for M1, correct. And if I2 acts as an object for M1, I can extend M1, drop a perpendicular from I2, draw the same distance on the other side and find the location of image of I2 in M1. Now, you can easily understand that it will exactly coincide with this position. So, this is once again the position where the image of I2 in M1 is formed. So, we can say that this is the position where image of I1 in M2 is formed, and similarly image of I2 in M1 is also formed. So, that is a coinciding image there. So, whenever two images coincide with each other, and if they ask you how many total images are formed, you have to say, you have to count this as a single image itself. You can't count them as two images, even though we know that it is forming because of two different kinds of reflections, because they are overlapping onto each other. We can only see it as one image. So, if they ask you what is the total number of images, in this case total images formed, so the answer for that would be 3, right. Okay. Now, let me slightly modify this question and see whether you will be able to think about that. So, what I am going to do now is I will take a mirror like this. This is a short one, only the mirror extends only till here. So, these are the ends of the mirror, this is just an extension, and let us say there is another mirror over here along the x axis or xz plane. So, we have two mirrors in this manner. So, they are not extending and touching over here, they are like this, as you can see the angle is 90 over here. Now, what I have done is I have placed a point object, let us say, let me draw two more lines over here. Okay. I have placed a point object exactly at this position such that this angle is 90 and this angle is 90. So, these two mirrors are once again at 90 degrees with each other, and we need to find out how many images are possible in this scenario. So, we have seen that in this particular scenario there are 3 images which are formed. In this scenario, how many images are formed? So, this is, let us call this as mirror M1, this one as mirror M2. So, will the answer be 3 in this case also, or will it be more than 3 or less than 3? So, we will see that. So, we know that wherever I place the object, whatever is the size of the mirror, direct images will anyways be formed. So, a light ray which is getting reflected from here will go like this, and it appears to come from a point which is over here. So, I can say that this is where the direct image of this object in mirror M1 is formed. So, I1. So, that image is anyways formed. Now, in the same, by using the same logic, I can say that the image of this will be formed behind at this position, and this would be the image of O in mirror M2. So, I will call it as I2. So, these two images are anyways formed. Now, what about the third image? What about the image of I2 in M1, or what about the image of I1 in M2? Can I take the reflection of this in M2 and draw an image over here? Is it possible? I can draw, but is that image going to be formed? So, for this you have to be very careful. I have told you earlier, image of an image will be formed if light getting reflected from one mirror goes on to the other mirror. If that is not happening, then image of image will not be formed. I will repeat once again. So, what I am trying to say is, for I2 to act as an object for M1, it means that the light which is getting reflected from M2 should reach M1. Now, looking at the scenario which I have given, is it possible? Is it possible for the light which once gets reflected from M2, can it reach M1 once again? So, you can draw any rays, you can draw some rays and understand. Draw a ray like this, draw a ray like this, take another ray. So, will any of these rays which get reflected from M2, will they be able to reach M1? Which means, let us say if these are the reflected rays. So, one light ray will get reflected over here, this light ray will get reflected like this, this will get reflected, this will get reflected. So, you can basically observe that the light rays which are getting reflected from M2, which appear to come from I2, they are all in this field of view. This is the field of view of I2, which means all the light rays which are reflected from M2, they appear to come from I2, but those light rays are in this region only. They are not falling on M1. So, this cannot act as an object for M1. So, that is the idea. So, only two images are formed in this scenario. So, this acting as an object for this is not possible, or vice versa. This acting as an object for this is also not possible, because any light ray which gets reflected from mirror M1 will go away like this. It can't reach M2 once again. So, finally, keep in mind, if the image of one, if it has to act as an object for the other, then the reflected ray from one mirror should be able to reach the other mirror, otherwise that case is not possible. So, in this case we can say that number of images is only 2. Now, I want you to think about a similar scenario. What if this object is placed, let us say, either in this region or in this region? Let me draw that once again here. Okay. So, in the earlier case we have taken that the object is exactly at that position. Now, what if I take an object here? In this case, how many images will be formed? So, think logically, there is no formula kind of thing for this. This is just a logical way of understanding how images will be formed. So, you know that direct images will anyways be formed. The image of this in this will be formed over here, and the image of this in this will be formed over here. So, we need to just look at whether the next one will be formed or not. So, will it? So, that can happen only if the light ray which is coming from here after striking this should reach this. If it is possible, then the next image will also be formed. So, if I consider a light ray which is striking this mirror, after reflection it will go away like this. So, if we consider that the mirrors are sufficiently long after this, so if the mirrors are sufficiently long, then we can say that a light ray which gets reflected from here might go and strike the next mirror, which means this can act as an object for this. So, the image of this in this might be formed over here. So, that is how we basically understand the formation of multiple images. So, what we have seen is a 90-degree scenario. So, we will now move for a general scenario, right. Now, one important thing I want you to observe in this, which would be very helpful for us in the next case, is that if you look at all the three images which are formed, the object, this is the object, and these three are the images. So, look at all those four and look at the distances at which they are present. So, this is one image, this is one image, and this is one image. So, we have three images and one object. Now, I have taken the coordinates as a comma b. So, we can easily say that from the origin, the intersection of the two mirrors, it is at a distance of root over a square plus b square. Now, what is the distance at which this is present? Root over a square plus b square, because the coordinates of this would be a comma minus b, and the coordinates of this would be minus a comma minus b, and coordinates of this would be minus a comma b. So, what you should understand here is that all the 4 points, one object and 3 images, all of them lie at the same distance from origin. So, all these are at same distance from origin. I am not drawing it, so because the diagram might get messier, but I hope you understand all of them are at the same distance. So, what that means is that when I draw a circle with the radius as root over a square plus b square, then it passes through all those 3 points. 3 images and 1 object. So, that is the basic idea. We can say that the radius of this circle is root over a square plus b square, right. So, we will be using this result in the next analysis for a general angle between the 2 mirrors. So, let us see that. Students, now we will discuss about plane mirrors which are inclined with each other, the location of the images formed and number of images formed. So, let us consider a general scenario, a method for finding out the number of images formed. So, let us consider 2 mirrors which are like this. they are inclined at some angle. Now, let us say that there is an object which is placed in between these two, somewhere over here. Let us consider from the intersection. Okay. So, from the intersection, let us consider that the object is at a position which is at a distance of r and making an angle of alpha with one mirror and beta with the other mirror, right. So, I will consider this as mirror M1 and this as mirror M2. So, that is the case. So, this is the point object at a distance from the intersection of mirrors which is equal to r, and it is making an angle of alpha with mirror M1 and beta with mirror M2. Okay. Now, from the earlier case we have understood that all the images which are formed, whatever be the number of images, all of them should lie in a circle with this as the center and r as the radius. So, first I will draw that circle so that it is easier to locate the images. So, first I will draw a circle of radius r. Okay. So, now we know that the images, all the images should lie on this circle. So, now let us see how many images are possible. Okay. So, we will be using some symmetry ideas here. We can say that because this object, let us say it is at this much distance, perpendicular distance, if I draw the same perpendicular distance onto the other side, so this is where the first image will be formed, and if this length and this length are same, and if I draw a line from here to the location of the image which is here, so we can easily say that the triangle which you see on the top and the triangle which you see on the bottom which are formed, they are congruent triangles, because this length and this length are same, this is a common side and there are two 90-degree angles. So, it has to be congruent, which means if this angle is alpha, then this will also be alpha. So, if an object is in front of the mirror at an angle of alpha, then the image formed will be behind the mirror at an angle of alpha. So, that is the idea which we can understand. So, now what we can now say is, because whenever we have inclined mirrors, we can easily say that a light ray which gets reflected from here. So, let me draw one light ray, or I will draw a different diagram for that. So, we can say that if a light ray gets reflected from this surface, it can go and strike the second mirror, that is a possibility, which means the image which is formed in the first mirror can act as an object for the second mirror. Yes, I have told you, the image formed, for it to act as an object, multiple reflection should happen. So, which means, so if a light ray strikes M1 and goes on to M2, that appears to come from this image. So, this now acts as an object for M2. Now, you know that just now we have discussed. Now, look at what is the angular position of the object with respect to M2. So, this one is at an angle of alpha plus beta. So, which means it is at an angle of 2 alpha plus beta with respect to M2. I hope this is clear. This image is acting as an object, and how much angle is it present in front of the mirror? Alpha plus beta. So, the image which is formed for this, so let us call this image as I1, clear? I1 is the image of O in M1. So, the image of I1 in M2 will be formed behind in this manner. So, whatever is this angle, same will be this angle. So, from mirror M2, whatever is the angle at which I1 is present, we can say that the image will also be present from M2 behind it at the same angle. So, this angle here will be 2 alpha plus beta. So, I will write it down over here. So, the next image will be formed over here, and the angle here will be 2 alpha plus beta from mirror M2. Clear? Now, it is correct that this light ray which is getting reflected can once again fall on the mirror M1, which means this light ray, this image which is formed can once again act as an object for M1. Yes, it is true. Now, to find that, see the logic once again. So, this object or this image is at 2 alpha plus beta from M2, which means from here if it is 2 alpha plus beta, from M1 how much angle is it present at? 2 alpha plus beta plus alpha plus beta. So, that is the object angle. So, you can say 2 alpha plus beta will be 3 alpha plus 2 beta. So, we can say that the image will be formed from M1 behind. So, this is 3 alpha plus 2 beta. So, from M1 behind it the image will be formed over here. We can say at an angle of 3 alpha plus 2 beta. And the same story repeats once again. This light ray which is getting reflected can once again go and strike the mirror. If the mirror is sufficiently long, we can say that this light ray can go and strike the mirror. This one can once again act as an object for M2. So, once again we do the same analysis. Okay. Now, what I have shown you here is just one half of the possible cases, because I have considered the image of this in this and we have continued from there. The same scenario can happen for the direct image of O in B, because O is at an angle of beta. So, O is at an angle of beta from M2, the direct image of that will be also formed behind M2 at an angle of beta. So, this angle will be beta. Now, the same story once again. So, this can once again act as an object for M1, but if this is acting as an object for M1, by now you should have figured it out. This is something similar to what we have done in the plane mirror reflection case. If one image is acting as an object for the other, we add the length between them in that case, we add the angle between the mirrors in this case. So, if it is at beta from M2, what is the angle at which it is present from M1? Beta plus alpha plus beta. So, 2 beta plus alpha, alpha plus 2 beta. So, we can say that the image of this in M1 will be formed over here at alpha plus 2 beta. Now, this is once again an object for this alpha plus 2 beta plus alpha plus beta. So, that is where the image will be formed behind M2. So, it will be formed over here, and the angle will be alpha plus 2 beta plus alpha plus beta, which is 2 alpha plus 3 beta, and so on. So, that is how you locate the images. So, what I have shown you here is a general case scenario. So, we can actually make a table out of this, just like how we have done in the case of plane mirror reflection with parallel mirrors. So, we can make a table exactly similar to that. So, let me erase this. So, in this case we can say M1 and M2. So, what I am going to do here is I am going to write the angles at which images are formed from M1 and M2. So, now by now you must have figured out the method. It is exactly similar to how we have done it in the case there with distances, here with angles. So, if it starts with alpha from M1 and beta from M2, what am I going to do? Alpha from M1 is at alpha plus beta from M2. So, I will use the crisscross method once again. So, if I add alpha plus beta, I get 2 alpha plus beta. So, which is what we got here. Now, for this beta, if I once again do crisscross, if I add alpha plus beta, I will get alpha plus 2 beta, which means the image of this in M1 is at alpha plus 2 beta, and the same repeats. So, we get 2 alpha plus 3 beta, 3 alpha plus 2 beta, and so on. So, that is the scenario. Now, unlike the earlier case where we had infinite images which are formed in the case of parallel plane mirrors, we can't do this for infinite angles, because there is a limited angle over here. So, we will have to stop it somewhere, and where do we stop it? So, you should realize that we need to stop those angles, or whenever we are keep adding the angles will keep on increasing, and at one point of time those angles will cross 180 degrees, each individual angle. So, let us say over here the value which you got has crossed 180 degrees. So, if the value of the angle has crossed 180 degrees, then you should not count those angles. Now, what is the reason for that? Why shouldn't I count an angle which is greater than 180 degrees? Because an image forming at greater than 180 degrees, if let us say there is a mirror like this and there is an object over here, and if the image of this is formed behind the mirror at an angle greater than 180, greater than 180 means if let us say this is the angle theta, so where the image is formed. So, now think about what will happen if this angle keeps increasing and the image location is changing, and what happens when the angle becomes greater than 180? It means that the image is in front of the mirror, which is definitely not a possible scenario. So, the image cannot be formed in front of a plane mirror. So, that is the reason why we do not consider the angles. So, wherever the angles cross 180 degrees, we will stop there. So, that is the basic idea, and we will see, we will understand this by using one example, then it will be clear for you. So, let us consider a case like this. Let us say there are two mirrors like this, okay. So, two mirrors which are inclined at an angle of 40 degrees, and there is an object which is placed in between them in such a way that with one mirror it is making an angle of 15 degrees and with the other mirror it is making an angle of 25 degrees. So, let us consider a scenario like this and let us make a table M1, M2. So, this is M1, this is M2. Now, let us find out how many images are formed. So, I will start off with 15, 25, crisscross. What is the angle between them? 40. So, when I add 40, I get 55. When I add 40, I get 65. When I add 40 again, I get 105. 40 again, 95. 40 again, 135. 40 again, 145. If I add 40 again, I get 185, which I shouldn't count. And similarly, if I add 40 again to this, I get 175, which is okay, that can be counted. So, if you look at this, how many images are formed in this scenario? 1, 2, 3, 4, 5, 6, 7, 8, 9. So, 9 images are formed in this case when the mirrors are at 40 degrees with each other and the object is placed at 15 and 25 degrees from each of the mirrors. So, understand this properly. It is a very simple method which is very effective also. So, just make sure that you stop whenever the angles cross 180 degrees and count the number of images formed till then. But there is one small catch here where you should be very much aware of. So, let us see that now. Now, this is a similar scenario as the earlier case, just the values are slightly changed. So, you can see the angle between the mirrors is 60, object is at a position of 20 degrees from M1 and 40 degrees from M2. So, we need to find the different images formed. So, I will just use the method 20 degrees, 40 degrees and crisscross, adding of 60 degrees will give me 80 here and 100. Again adding 60 gives me 160 here and 80 plus 60 is 140 degrees here, and if I add 60 more it crosses 180 both sides. So, I will stop here. So, now when you look at this, you have 1, 2, 3, 4, 5, 6. So, what is the number of images formed in this case? So, from this method you are getting that it looks like it is 6, but the answer for this is actually 5. So, this is what you should be very careful about, and the reason, can you guess what the reason might be? So, the reason is something like this. So, when you look at the two angles which are formed at the end, the 140 degree and 160 degree angles, it means that this image which is 140 degrees, which is at 140 degrees from M1, let me just represent it like this. So, from here it is at 140 degrees. So, let us say it is somewhere over here. So, 140. So, this angle here is 140 degrees. Okay, fine. Now, this image is at 160 degrees from M2. So, what happens here is that when I draw a 160 degree angle, so that 160 degree angle exactly coincides with this line. Now, how do I know that? When will 140 from here and 160 from here coincide with the same line? It happens when 140 plus 160 plus this angle becomes 360. Think once again. So, you know that this angle is 60 degrees and the whole angle is 360 degrees, which means if I leave out this angle, the remaining angle is 300 degrees. So, what does it mean that the sum of these two is 300? It means that when I go back from here by 140, I am coming back from here by 300 minus 140, which is 160. So, that is the reason the two images which I have represented here, they are coinciding with each other. So, these two are overlapping images. So, they shouldn't be counted as two different images in this case, because 140 from mirror M1, 160 from mirror M2 are one and the same. So, this image and this image, they just form on each other. So, they should be counted as one image. So, whenever you need to check whether the last two images are coinciding or not. So, let us call this angle as theta 1 and this angle as theta 2. All you will have to do is check if theta 1 plus theta 2 plus angle between mirrors, So, if this angle, if this is equal to 360 degrees, then there are overlapping images. So, overlapping happens, and whenever overlapping happens, you shouldn't count the last two images as two images, you should just take it as one image. So, that is the general method. So, use this for any scenario which they give you, whatever is the angle which is given between the two inclined mirrors, you can just follow this method. But one thing you should be very careful is about the last two angles. So, do not cross 180, and the last two angles plus angle between the mirrors, if it is equal to 360, then subtract 1 from the overall values which you have got here. So, that is the basic idea of finding the number of images which are formed. So, we actually have a formula for the result which we have derived earlier, but that formula cannot be used every time. So, I suggest you use the same method which we have discussed earlier, the crisscross method, even with the inclined mirrors case. But I will anyways give you the formula for understanding the number of images formed. So, if we have two mirrors which are inclined at some angle theta with each other, right. So, in this particular case, so we are going to find out one particular value which is 360 by theta. So, if I calculate 360 by theta and if we get n, and if n is an integer. So, let us consider that whatever I am going to do now is only for if n is an integer. So, if n is not an integer, then we can't use this formula which I am going to tell you. The only method you can use is the earlier method which we have talked about, the crisscross method. So, these formulas are useful only when n is an integer, n means 360 by theta. Okay. Even in this case there are two possibilities. One, if n is even, then number of images formed is n minus 1. Now, in the same manner, if the value of n is odd, then number of images is equal to n itself. So, that is the idea. So, the reason why we are subtracting 1 in the case where n is even is because the last 2 images in such a scenario will overlap with each other. So, remember that whatever I have written here is only applicable if 360 by theta is an integer, and if it is even, subtract 1 and make it odd. If it is odd, let it remain as odd itself. So, that is the basic idea. So, which means when 360 by theta is an integer, you should always get odd number of images. So, that is the case. Okay students, now let us discuss about the velocity of image. So, we will now discuss in the case of a plane mirror, if the object is moving and the mirror is also moving. So, in such a scenario, how to find the velocity of image, right. So, for this, so I will consider the plane mirror scenario. Let us say that the plane mirror is like this and there is an object over here. So, in the first case, what I am going to derive now is the case where the object and the mirror are moving in the perpendicular direction along the normal direction. So, this is the normal direction. So, all the velocities which I am going to consider now for the object, for the mirror will be in the normal direction. So, the object will either move like this or like this, mirror also will move either like this or like this. So, all velocities along normal. All velocities are along normal. Okay. So, let us see what happens in this case. So, this is the object. We know that the image of this is formed on the other side at exactly the same distance. Now, because we are trying to do a general derivation, we can easily say that if the mirror is at rest. So, mirror at rest case is a very simple scenario, because if the mirror is at rest, we know that if the object moves by x, then the image should move by x as well, because object and image should always be at same distance from the mirror. So, what we can say is, what if the object has a velocity of u, then the image will have a velocity of minus u, same magnitude in the opposite direction. So, yeah, that is pretty simple to understand. So, what I will do is, I will do a direct derivation for what happens if mirror is also moving, right. So, if mirror is also moving, how do I find the velocity of image? So, let us see that now. So, for that what I am going to do here is, I will call, because mirror might move, we know that the object distance and image distance with respect to mirror should always be equal in magnitude and opposite in direction. So, whether the mirror moves, object moves, image moves, whatever be the motion of the individual elements, this might move, this might move, this might move. But in each and every scenario, one relation should hold true, and that is the object distance and image distance with respect to mirror should be equal. So, this is the standard property of image formation in a plane mirror. So, however they move, the object distance and image distance from the mirror should always be equal in opposite directions. So, I am going to use that idea here. So, let me write, because all the directions, all the lengths here are measured along x axis. X axis is the normal in this scenario. So, I will represent it with x, the distances I will represent it with x. So, what I can write here is that the position of the object with respect to mirror, I will write it in vector form, because I will also include that if object is on one side, image is on the other side. So, to represent direction, I am using vector here. So, the position of object with respect to mirror should be equal to the negative of the position of image with respect to mirror. So, remember that this negative sign here, the only information that it gives us is that from the mirror, if one is in this direction, the other one is in that direction. and the magnitude should be equal. These are distances of object from the mirror, image from the mirror. Now, we are concerned about velocities. So, what I will do is I will just differentiate it. I will just differentiate this expression, because I know that differentiating a particular position will give me the rate at which that position changes, which is the velocity. So, differentiating, what am I going to get is velocity of object with respect to mirror is equal to negative of velocity of image with respect to mirror. So, this is the relation which I got. Now, so observe carefully. So, from your understanding from relative velocity in the first year, you know that velocity of A with respect to B basically means, what do we mean by velocity of A with respect to B? So, you all know this. This can be written as velocity of A minus velocity of B. So, the relative velocity of A with respect to B is the absolute velocity of A minus the absolute velocity of B. So, I will just use that here. So, velocity of object with respect to mirror can be understood as velocity of object minus velocity of mirror is equal to negative of, how can I write this, velocity of image minus velocity of mirror. So, now considering that I know the object's velocity, I know the mirror's velocity, I need to find the image velocity. So, I will make image velocity the subject here. So, I will get velocity of image is equal to, so please observe carefully, if I send this side, this minus and minus becomes plus Vm, another plus Vm. So, I have 2 Vm minus Vo. So, this is the relation, a very important relation. So, the velocity of image is equal to 2 times the velocity of mirror minus velocity of object. Now, there are two things which you will have to keep in mind here. Case 1, just check whether what we discussed earlier is valid or not. So, if object moves and mirror is at rest, so if object is moving and the mirror is at rest, so check what happens in that scenario. If the mirror is at rest, are we getting velocity of image is equal to negative of velocity of object, which is what we discussed earlier, right? So, without the mirror moving, if object moves like this, then image moves like this with the same velocity. So, which is what we got here, right? And in the same manner, if object is at rest, and mirror moves, and in such a scenario you can see that if I make the velocity of object 0, you would observe that velocity of image is equal to 2 times velocity of mirror. This is an important relation once again. So, the important thing here is you will have to understand that if the object is at rest and if the mirror is moving, let us consider that this is at rest, and let us say mirror is moving with some velocity of 5 meter per second towards right. Clear? In such a scenario, what will be the velocity of image? 10 meter per second, and the important thing here is the direction once again. So, whatever is the direction of Vm bar, same will be the direction of Vi bar. Is that clear? So, if the mirror moves in one particular direction, the image also tries to move in that direction. So, please keep in mind whenever you are using this particular result, make sure that you are using it with signs. So, by looking at the directions, use positive for this direction, right, use negative for this direction. So, do not forget to substitute the sign convention in this particular scenario. Now, keep in mind that all these results which we have discussed till now is valid only for the direction which is normal to the mirror, which means in this case horizontal. So, now what happens in the case if the object, mirror have velocities perpendicular to the mirror? So, let us, not perpendicular to the mirror, perpendicular to the normal. which means in the plane of the mirror. So, let me write it down here. If velocities are along the plane of mirror. So, what we have discussed earlier is a case where the velocities are perpendicular to the plane of the mirror. Now, we are going to see the velocities, what happens if the velocities are along the plane of the mirror, which means, okay, I will draw a different diagram here. So, object, mirror, let us say the object is moving like this. So, this is the normal to the mirror. So, if the object is moving like this, or let us say if the mirror is moving like this, in such a scenario what will be the velocity of image which is formed. So, the mirror which is over here, it can move like this or like this also, because I am talking about the plane of the mirror. So, remember that if according to the diagram, considering that this is x, this is y and the outward direction is z, the mirror is lying in the yz plane. So, whatever analysis I am going to do now, I will be using y, I will be explaining it by using the y direction, but remember that everything of this analysis is also similarly applicable for z direction. So, if I am taking the velocity of this in y, mirror in y and finding out the velocity of image in y, so remember it is also applicable for z direction, because z direction is also parallel to this mirror. So, the mirror is in this plane. I hope you are getting this. So, this is the mirror. So, this is y, this is z. So, whatever I am going to do now for y can also be applied for z. So, please keep that in mind. So, once again I will use a similar method for understanding, because both can move in this scenario as well. So, if I consider that the object, let us say, has travelled from here to here in this case. So, I can say that the y coordinate of the object with respect to mirror, let us say, let us define one particular point as origin on the mirror. So, whatever is the y coordinate of the object with respect to the mirror should also be equal, because if this moves from here to here, the image will also move from here to here. So, we can say that that should be same as the y coordinate of image with respect to mirror. So, I hope this is clear. So, if we have a mirror, so we can say that if I take one point as reference on that mirror, so with respect to this, if the object is at a height of y, then with respect to this point, image should also be at a height of y, right. So, that is what I have written here. Now, once again differentiating this expression, so if I differentiate it, I would get velocity of object with respect to mirror is equal to velocity of image with respect to mirror. Now, expand that by using the relative velocity concept, you would get velocity of object minus velocity of mirror is equal to velocity of image minus velocity of mirror. So, if you see clearly, both sides velocity of mirror gets cancelled out, and you will finally get velocity of image is equal to velocity of object, which means in the plane of the mirror, I will repeat once again, in the plane of the mirror, the velocity of the mirror does not matter. So, whether if let us say I have a mirror in front of me, if I am standing in front of the mirror, let us say I am at rest. So, if the mirror moves perpendicular to it, then the image will also move in that direction. But if the mirror is moving in its plane, so let us say the mirror is like this, it is moving either like this or it is moving like this, the image is not going to change its position. So, the motion of the mirror in its own plane, so if the mirror is like this, however I move this mirror in its own plane, that is not going to affect the motion of the image or the position of the image. So, think of it, it makes sense as well. I have told you earlier that whether the mirror is, let me write it down over here, if the object is over here, if the mirror is either like this or if the mirror is taken to a different position like this, let me redraw it. So, in this particular case, if the object is like here and the mirror is like this, the image will be formed over here. So, we have discussed earlier that if this mirror is taken from this position and kept here, even then the image is at the same position, right? Or if the mirror is taken from this position and moved like this, even then the image of this will be at the same position. So, which means this is a very, very important result. Remember that the motion of the mirror or the movement of the mirror in its own plane is not going to affect the image in any manner. So, I will write that point down here. The motion of mirror in its own plane doesn't affect the position or motion of image. So, a very important result that is. So, please keep that in mind. So, to summarize, we have discussed two cases. One is if the mirror and the object are having velocities along the normal. Along the normal means perpendicular to the mirror. So, when the velocities are perpendicular to the mirror, so this is the result we will be getting. So, this is something which you will have to remember for sure. So, you can't do this derivation each and every time a question is asked. So, please remember that. So, this is applicable only in the cases where the velocities are perpendicular, and in the case where the velocity is parallel to the mirror or in the plane of the mirror. So, in such a scenario we can say that mirror's motion does not affect the image's motion. So, in such a case whatever is the velocity of object, same will be the velocity of image. Clear? Okay. We will solve some examples based on this now. So, students, let us solve some questions now. So, here it is given that the mirror is in the xz plane. So, xz plane means this plane, horizontal plane, right. Where they have given the velocity vector for the mirror, object's velocity as well, and they are asking us to find velocity of image. So, we know that the analysis of image velocity should be done in two ways. We have to do the perpendicular direction separately and the plane of the mirror separately. So, we will see that. So, let us first observe the normal, because the mirror is in the xz plane. So, we can say that y axis is the normal. So, first let us complete the y axis analysis. So, along y. So, along y axis basically means along the normal to the mirror. We know that along the normal to the mirror, velocity of image is equal to 2 times velocity of object minus 2 times velocity of mirror minus velocity of object. So, I will directly apply the formula and I will get velocity of image is equal to 2 times what is velocity of mirror in y direction. Velocity of mirror in y direction is minus j cap, right, minus velocity of object. Velocity of object in y direction is minus 2j cap. So, this is minus 2j cap. So, when you simplify this, this becomes 0. So, that is the velocity of image along y axis. Now, similarly along x and z axis we can write it directly, because you know that x and z both are in the plane of the mirror. So, for both we can write the relations in the same manner, and in this case we know that velocity of image is equal to velocity of object directly. It does not depend on the velocity of mirror. So, this piece of information and this is not useful for us. So, whether these are different values or if they are zeros, whatever be the value of these two, we get the same answer, because velocity of mirror in the plane of the mirror is not going to affect the velocity of image. Okay. So, now I can write velocity of image along x and z is equal to velocity of object along x and z, which is this and this. So, 4I plus k cap. Now, combining these two will give me the net velocity of image, and that can be written as because this is anyway 0, we can directly write it as 4I cap plus k cap. So, that would be the velocity of image in this scenario, right. Okay. Let us see one more question. So, here they have given, they are asking us to find out the velocity of third image which is formed in mirror M1. So, they are asking us to find third image which is formed in mirror M1, its velocity. So, because there are multiple mirrors here, so we know that the location of the third image will depend on this distance as well as this distance, correct. So, what I will do is I will represent this distance as A and this distance as B. So, the mirrors are at rest in this case, mirrors are at rest. So, this question has nothing to do with the earlier case, the formulas which we have derived. So, we have to understand this logically and solve. So, because as this object moves towards this mirror, A changes as well as B changes. A decreases and B increases. Now, A decreases at a rate of 1 meter per second, correct, because the object is moving like this with 1 meter per second. The distance between the object and the mirror M1 decreases at a rate of 1 meter per second. Now, I can also say that this distance B increases at a rate of 1 meter per second. So, let me write it down first. So, from the information which I see in the diagram, I can write dA by dt, which is the rate at which A changes. Because it is decreasing, I can write it as minus 1 meter per second. Now, B here is increasing. So, I can write dB by dt is equal to 1 meter per second. I guess by now you must have understood why I am calculating dA by dt and dB by dt. Do you have an idea why I am doing it? Because I am directly going to find out where the third image is formed, the distance at which the third image is formed, and I am going to find out at what rate that distance is changing. I hope you understand that. So, let us make the table which we usually do using crisscross method. So, A from M1, B from M2, A, B, add A plus B, you get 2A plus B, add A plus B, you get A plus 2B, add A plus B, add A plus B, you get 3A plus 2B, and here you get 2A plus 3B. We need third image in M1. So, this is third image in M1. So, let me represent that distance. If let us say third image is formed from here, somewhere over here, then this distance will be 3A plus 2B. So, this distance of third image from M1 is 3A plus 2B. Now, we need to find out, can I say that the velocity of third image basically means the rate at which this length changes, correct. So, whatever is its distance from this fixed point, the rate at which this distance changes will be the speed with which it is moving. So, what I am going to do now is directly differentiate it to find out at what rate it is changing. So, velocity of third image is equal to d by dt of 3A plus 2E. Now, what do I get here? D by dt of this will be 3 times dA by dt plus 2 times dB by dt. Substituting the values, I get 3 times dA by dt. dA by dt, we understood that it is minus 1 plus 2 times dB by dt. What is dB by dt? We got 1. So, solving this will give us the value as minus 1 meter per second. So, which means the third image is moving with a velocity of 1 meter per second. Now, what does this minus sign indicate? Does minus sign indicate that it is moving in the negative direction? Is that what it means? So, remember that because we have understood this signs as rate of change, because we have considered that A is decreasing, B is increasing at a rate of 1, what we have found here is also the rate at which this length is changing. So, if let us say the image is formed here, and if this is the length, which is 3a plus 2b, so this length is changing at this rate, and if I got a negative value, it means that this length is decreasing. Now, when will this length decrease? This length decreases if the image formed is moving in this direction. So, if it moves like this, only then this length decreases. So, whenever you are using this method, the differentiation method for understanding the velocities, remember that the positive signs and negative signs, they may not represent the direction directly, they are going to tell you the rate at which they are changing. So, if it is negative, it means that the value which you have taken is decreasing. Now, you should understand, for that to decrease, what should be the direction. So, this is the method which we should use to find out the velocity of image in such a scenario, right. So, yeah, 1 meter per second towards left in this case. I am telling you once again, the reason why I wrote left here is not because this is negative. Because this is negative, this length should decrease, and if this length should decrease, then this image which is formed should move towards left. I hope that is clear for you. So, that is what you will have in the case of plane mirrors. So, we have covered more or less all the concepts. So, the rest is up to you to practice. You will be given worksheets every day. So, make sure that you are completing them on time, and in the next class we will be starting with spherical mirrors, convex, concave mirrors and cases like that.